This is code.org, and this is loop practice. Well, loop stuff. We're going to be doing loops, repeat blocks. We're good at them. We will be good at them. Let's go! And this is a B. Let's see what we're doing. We got one item in our workspace, yep, our win run block, and we can use up to 16. So collect all the honey and make all the nectar? No, they mean collect all the nectar, make the honey. That's going to mess with my head. All right, actions. Let's go ahead and move forward. And I'm just going to throw stuff down here to test it. Great thing about code, you can always debug, you can always be wrong. Let's try 2 move forwards just to get us going. I'm going to hit step, and I can watch now what line of code runs. Move forward, check. Move forward, check. Cool. All right, well, obviously we're not there yet. And we need to be getting the nectar from the flower. So let me go into actions. Nope. Wait. Yep, get nectar. Flower has nectar. It's not make nectar. Get nectar. Let's see how this goes. Move forward, get the nectar. Yep, that's looking good, right? Move forward, you get 1 nectar. Notice it's a 1, now it's a 0. Now we move forward again, and now we can make some honey. All right, so that's one side of this, and that's looking good. I'm going to guess we're turning to the left after that. And then let's just try some stuff out again. Move forward. Looks like another flower. And then move forward. Looks like some honey. Let's see how this is. And notice they're all 1s here. Let's see what this does. Okay. Oh, and then we're going to turn forward. Looks like there will be a flower there. Get its nectar. Forward. Make honey. Now this should work. Well, let's see. But there's a better way, a faster way to do this, right? We got it all. Now, let's take a look at this. It's called a loop. While there's a path ahead, a repeat. So in code, if you're repeating yourself, there's probably a better way to do it. And I'm going to show you. Let's break out. Actually, if I'm at the very end here and I turn left, would that break anything? Would it harm anything? It wouldn't. So, now that we know that, let's go ahead and look. Move forward, get nectar, move forward, make honey, left. Move forward, get nectar, move forward, make honey, left. Move forward, get nectar, move forward, make honey, left. These are identical. So instead of doing this in 16 blocks, again, identical, what if we did something like this? Repeat, how many times? Well, let's do it 3 times. Let me get rid of this and drop this in this pink box mouth thing. All the code inside of this pink mouth thing will run 3 times. It will go through, turn left at the bottom, hit the bottom, and go up 2 more times. Zoop. Go all the way back through, up 1 more time. And we'll go around the 3 sides. Victory! Onward. This is a bee. Finish this code so that the bee can collect all the honey and the nectar. Wow, they gave us a lot of code here, and we already have 13 blocks. All right, let's check this out. Well, if I hit run... Oh, weird. So we're missing stuff here. Let's see. Repeat 3 times do. Do what? Move forward. Well, how many times am I going to want to move forward? I'm going to set this to the side just to kind of help me out here. Let's see. It looks like I'll want to go forward, what? Twice? And then what? Looks like I would go forward twice. I would get nectar, what? 1 and 2. And then, let's see. Once, always use step. It's super helpful. Get nectar. Yep, that's looking good. Then I go for it again, and I would make honey. Twice. Okay, this helps me out. Then what? Well, it looks like I would turn left, and then I think I'm going to do the same stuff, right? Move forward 1 and 2. And this is why they're using a repeat, right? I would need to get nectar, because the sides, you have to do the same actions. Move forward, make honey. Okay, so why we're using this big repeat here is this, right? Why do this more than once? Now, this should help us figure out, though, right? Move forward. How many times do we move forward? Looks like 2 times. So let me go over to math. That's not what they want. They don't want us to go to math. We have what's called a variable. Counter is equal to 2. So in math, if you see x plus 1 equals 3, x plus 1 equals 3, what's x then? X would be 2. Counter right now is 2. So I can go ahead and drop this in here, but instead of putting a number, I can use the word, well, maybe. Oh. All Are they making me? Yes. I can go up here and go ahead and drop in the word counter, since I know that's 2. How many times do I get nectar? Oh, counter times. Oh, how many times do I make honey? Oh, counter times. And what's nice about this is that if for some reason the puzzle changed and got a lot longer, I'd only have to put in, maybe I need a 4 here. Everything's 4 times. A 4 once, instead of going through and changing it all. There's other benefits to this too. But you can see, so now 3 times in a row, just like we needed to do with our original code, we're going to do all of this, and each one of these repeats it. Let me just make sure we're getting this. So counter is a number. Counter means the number 2. I hit step. The computer knows everything inside this pink mouth is going to run 3 times. First, I need to run this chunk, though, 2 times. So I'll move forward once. Twice, I'm done with this chunk, this inner pink thing. And I drop below, and now I got nectar once, twice, so on and so forth. Onward. This is code.org. Oh, did they give us everything? Change the starting value of the variable so that the bee can collect all the honey and the nectar. Let's see. I'm going to hit step so I can see what's going on. So right off the bat, we have a variable, counter. Counter is equal to 2. It's just like in math when x sometimes mean a number, right? X plus 7 equals 10. X plus 7 equals 10. X would be 3 there. Counter is equal to 2. So everything in this big pink mouth thing, loop box thing, we're going to run 3 times. First thing we do is repeat, and the computer doesn't see the word counter. It says counter. What the heck's that? Smack. 2. Okay, I got to do this twice. Move forward. I move forward once. I move forward again. Now it's done this twice, and we're going to fall below. Except there's an error already, because it knows I'm about to try to get nectar. There's no nectar here. So how many times do I have to step? Oh, it looks like I would move forward 3 times. How much should I get nectar? Oh, 3 times. How much should I get honey? 3, or make honey? 3 times. So now I can just change this number counter. It's going to change here, here, and here. Because when the computer sees counter, it means 3. I don't have to go down here and write, oh, this was 2, now it's 3. Delete 2, write 3. I can just change it once. Like magic. Awesome. Onward. In this puzzle, each patch is 1 space further away and has 1 nectar to get 1 more honey to make. And has 1 more nectar to get 1 more honey to make, right? So step once, get nectar. Step once, make honey. Step twice, get 2 nectar, get 2 honey. So if I run this right now, I'm going to hit counter. Counter is equal to 1. So the computer says I got to do all this code 3 times. But first, I need to do repeat counter. Oh, what's that equal to? Smack. 1. Repeat 1 time. I'll move forward once. Hits this again. Falls below because it's done that 1 time. Repeat 1 time. Get nectar. So I'll do that. Boom. Now I've done that 1 time. I'm going to move forward here. Now I'm going to fall below. And what am I going to do? Repeat counter times. 1 time. Make honey. And now I'll turn left. Now, I have to do this whole thing 3 more times. Well, counter is still equal to 1 here. So that's a problem, because I need to go 2. So how can this be solved? Change the variable by 1 at the end of a loop. So let me head over to variables, and look, we have a change by 1. And what this is going to do is at the end of the loop each time, we're going to add 1 to counter. So that means when we turn left, boom, counter is now equal to 2. It goes back to the top, and now it will repeat twice, move forward. Twice, get nectar. Twice, make honey. Turn left, counter was equal to 2 there. Boom, counter is now equal to 3. We add 1, hits the bottom because it has to do all this again. Now we'll move forward 3 times. 3 nectars, 3 honey. And just like that, we are saving a ton of time because instead of getting all of these blocks out for all the different steps, we can use a variable. Onward. Let's see what we have. This puzzle follows the same pattern, but it is extended to a 4th. Add 1 number to the number of times the loop repeats to continue. Oh, right. So it's going 1 more leg here. And that's fine because we already have all of this code in a big repeat on the outside. So right now we're only going to get to here because we're asking it to run 3 more times. But if once we're done running it 3 times, right? So counter starts at 1, get down here, counter becomes 2, goes all the way back around, counter becomes 3, all the way back around, counter becomes 4, but then it's done because we're only running it 3 times. Well, if I change this to 4, counter would be 4, and it will run one more time. Yeah, onward. What's different this time? In the last couple puzzles, we need to change the variable by 1 each new patch. This time, each patch is 2 spaces away and has 2 more nectar to make honey. Well, if it's 2 away, if 1, right? If we're changing 2 each path, what could we do here? And there's no nectar, so that's going to err. Now, you can try all sorts of things, but honestly, this should be relatively easy. We do have to be 1 at first, but once we turn, right, counter isn't going to need to be 1, and we can't just add 1 to it, because how many flowers are there? How much honey do we need to make? 3. So we can't just add 1 to it, we need 1 to become 3. And then once the counter is 3, what are we going to have to do? Well, once counter's 3, once we're done with that, we'll have to make counter 5, because then we have to step 5 times, get 5 nectar, make 5 honey. Okay, well, what's 1? How does 1 become 3? How does 3 become 5? What if we change counter by 2? And so at the end, counter becomes 3. We go back around for this one, hit the bottom, counter's at 3, counter becomes 5, go all the way back around. Okay, Google, stop. Awesome. Onward. Finish the code to solve the puzzle. What could the value of the variable be at the start? Well, I'm going to do what I often do. I'm pulling all this to the side, and I'm just going to start throwing down code. Let's try stuff out. So it looks like I need 2 steps, right? So I wonder if that's a pattern. Oh yeah, we're going to need 2 nectar. And 2. And then what? Move forward 1. So we are noticing a pattern here. And then what? Honey. 1, 2. And then a left turn. So we've seen this a bunch. And then move forward how many times? 3 and 4. Okay. Then what? Well, it looks like I would have to grab 4 of these, but let's see. Yep. So this is looking familiar. So if I'm starting with 2, and this is why it's nice to map it all out here, and then I go to 4, okay, then what do I go to after 4? It looks like we need to jump up to 6. So how much am I going up by each time? 2, then 4, then 6. So I'm going up by 2 each time. This lets us see a few things here. First, what do we want to start at? What do we need our variable counter to be? Well, if we need to start at whatever that is, right? So it looks like we would start at 2. Now, the distinction here is how many times do we want to loop? Do we want to loop counter times? No, you don't want that to change as you go, especially because counter is going to be changing. You don't want this loop to vary. You want the stuff inside of it to. So, 1 side, 2 sides, 3 sides. Looks good to me. 3. Now what? Well, we have one more task. We're going to go through this 3 times and we start at 2. How much should we change? Well, to go to 2 to 4 is how much? To go 4 to 6 is how much? You want to change it, I hope you're yelling at your computer, by 2 each time, right? Each time this loop runs, we want to add 2 to it. If you're struggling with this, make sure you go back through, watch the other tutorials on these earlier parts. They're really critical to understanding how this is going to run. So we loop all the way through. 2 more is added to counter. We go back around. Counter is now equal to 4. Now counter is equal to 6. 6 nectar, 6 honey, turn left, and we're done. Onward. Alright, let's see what we got. Create your own code to solve this puzzle. Win run. So we got 1 block. We can use up to 24, but hopefully we know how to use the loop at this point. However, I want to do the first chunk without. It makes it easier for me to think. So I'm going to move forward once, right? And then we need to get the nectar. Then I'm going to move forward and get some honey. Make honey. And then what? Looks like a right turn. And then it looks like we're going to move forward once, twice. Interesting. Let's see. So far, so good. And now, oh, this is a bit different. They're spacing them out. Now I'm going to need to get nectar, not once, but twice. Then what? Move forward 2 more, it looks. And then looks like making honey. And then right turn again. Yep, so all that's looking good. So on these turns, that's where we can use a loop, because we have similar code. The only thing that changes is the number of times we perform an action, right? And this is why a loop with a variable works so well, because forward, two forwards, get nectar, two get nectars, move forward, two forwards, bake honey, two bake honeys, right? It is these same steps, just a different amount of times. So that's great. We know a variable will work. That being said, let's go ahead and plan out where we want our repeats first. So repeat, and I'm not going to use a variable just yet. I am going to put in the number right here. So I know move forward, right? Obviously we need that to increase. So I'll put move forward in a block. Now, what else increases? Well, get nectar once, here it's twice. Okay, that's a pretty good indication we can use a loop. And I'm actually going to grab several of these, because we're going to need one for anything that the amount of times it's changing. So get nectar, like we just said, we'll put that in a loop. Now how about move forward? Oh yeah, we're going to need that. The amount we move forward changes once again. Go ahead and stick this there for now. And then we're going to need one more loop, because once again, make honey, the amount of times we do that changes. All right, so we got those in loops now. Let me get rid of this. The only thing that shouldn't be in a repeat is turn right. We were only doing that once. Now this is great. This will get us through the first thing and we'll turn right, because all of these are 1, right? And now what? Well, now we want to go down this side and have them all be 2. We could remake all of this and have the number be 2, but that's ridiculous. Why not use, I'm headed over to loops, a repeat counter loop. Repeat counter times. Now this is not going to be happy. Why? Why? What's the error here? You got to tell the computer what counter is. It's not going to automatically know. So it says, what the heck is counter? And it can't run because it just means nothing. So let's head to variables and let's set counter. And we got to do the set before the repeat block. We have to tell the computer what counter is going to be equal to before we ask it to use that. So now it knows, okay, counter's 1, and it'll repeat everything 1 time, right? Oh, well, we actually, though, don't want that there. This is going to be hard-coded. What I mean by that is there's always only 3 sides. So, 3. There we are. Now, we want to use counter, and like I said, we need to tell it what it is before we use the variable. Here, right? This outer one isn't going to change. There's always 3 sides. The inner one, yeah, that's when we move forward more, right? Each round. Or nectar, we need to grab more nectar each time. Move forward again to the second part. Make honey. Yep, those are what vary. The amount there varies. And that's why we're going to use a counter variable. And now, how much does it change? How much does our variable vary by? What needs to be the difference as we move around? Well, we start at 1, we go to 2, and then to 3. So it sounds like we're adding 1 to it. Make sure, though, we need to add 1 to it at the end of all of this. Because then, when it loops back around to the top, counter starts at 1, we go through all of this, we move once, because counter's 1, we got to repeat this 1 time, move forward once. Counter times, we need to make honey once. Now we're going to turn right. We hit the bottom. Counter was 1, but up change counter by 1. So counter would be 2 now. We hit the bottom of this outer loop, and we still have to go around it 2 more times because it's a 3. So now we're back up here. Counter is equal to 2. The computer says repeat counter times. What is that? Oh, it's 2. So we'll move forward once and then twice. Drop below, because we've done that twice now. Repeat counter times. The computer says, what's counter? Oh, it's 2. We get nectar once, and twice. Onward. Do you recognize the staircase pattern from other level lessons? Yes. Yes, we do. Give it a try. All right, like usual, I'm going to just try with blocks first, no loops. Move forward. Let's go ahead and get the nectar. Oh, we got a turn. Let's make sure here. Step, move, yep. Step, get nectar, yep. Turn, yep. Move forward, yep. Make honey. Cool. Looking good so far. Then we got to turn left. And let's keep going. That will get us here. Now this is super long, but watch what this will do. Oh, did I turn the wrong way? I did. Oh, make honey. See, I'm skipping steps. This is what's great about coding. Be wrong. Be wrong a lot. Debugging. There we are. Great. So that gets us all the way to here. The reason I did all of this, though, right, is because I want you to see the pattern. Turn left, move forward once, get nectar, turn right, move forward, make honey, turn left. Move forward twice, get nectar once, twice, turn right once, move forward twice, make honey once, make honey twice, turn left. Then what? Well, then we're going to up it to 3, right? So this is where our variable will come into play, because it changes. The order of the actions are the same, but the amount of times we do them is different. So I know we're going to want to use counter. So repeat counter times. Well, what's changing? Forward, that obviously changes how much we do that. So does get nectar, right? 2, 3. Okay. Now turn right once. We're only going to need to turn right once. We're not going to want to go in circles. So that's fine. Now what? Move forward. Yeah, we know this changes. We can go to that. Make honey. Yeah, that changes. And then turn left. No, we only turn left once. Okay? So this is great. Now we have all of this ready to go. What number do we want to start with? What number is way up here? 1. If I hit run right now, it has no idea what to do. Counter doesn't exist. So let's tell the computer counter is equal to 1. So that just means it's going to hit these repeats, and it's not actually going to repeat because it only has to do it once. But we'll get through this first set, and it's done, right? And this is where our loop comes into play. That only gets us to here. So now we can use another loop, and how many sides are there? A lot. 1 step, 2 steps, 3 steps, since we're going down a set of stairs. And so now let's drop this here, but counter's still not going to update. Each set of stairs, each step, 1 step, 2 step, 3 steps, we need to go up by 2. So we gather 2 more. Or do we need to go up by 2? Let's see. 1, then 2 to the 3. We need to go up by 1. We need it inside of the loop, though. So where's my variable? Change by 1. Because if I drop it down here, this code only runs when we've run this whole thing 3 times. We want it inside of this, because that way, each time we run this 3 times, it will go up by 1. Counter starts as 1. Hit the bottom of this, it's now 2. We go back around through the steps, then it becomes 3, back around. Counter would then be 4, but we've run that 3 times, so the outer loop's done. And we got it. Victory! Onward. Alright, let's see. This puzzle's a little different. What do you need to solve it? Oh, it's wide open. Alright, I'm going to start how I often do, throwing down blocks. Okay, let's try this. Great, so move forward twice, make honey. Okay, I'm going to keep going. Let's see how I can get up here, because that looks to be the closest. And obviously this amount of times is going to change, so I'm going to go ahead and put this in a repeat. 1, 2, 3 it looks like. And then how much honey? 3 times. But first, why don't I turn before this? Doesn't matter, I could turn at either point, but then I'm going to move forward once. And 3 times again. Okay, then what? Well, then I'm going to have to go forward 5 times. Let's see how we're doing. And I'm already over. We can only use 17 blocks. Oops. I didn't even do that enough. Oh, that's interesting. So what appears to happen here is this one's 1 more. Now, how about when we go over here, I would need to move 5. 1, 2, 3, 4, 5. It's 1 more each time. Ah, we have a few options then. Okay, let's go ahead though. We know we need repeats, right, for some of these actions. And so to start out, we move forward 2, 1, 1. Then we move forward 4, 3, 3. Move forward 5, 6, 5, 5. Okay, so we have the base action here. I'm going to get rid of these. That looks good to go. And then I am going to need a loop. And like we have been doing, let's go ahead and the outside loop, how many sides? 1, 2, 3, 4. So that's how many times I'll have to do all of this. and bam. And then with that, I want to use counter, right? We want to be able to use a variable because this is going to change. It's not going to be able to go 3. We need to go 5 next time. Okay? The great thing about code too, not change set. We'll use that, but that's fine. Is that there's more than one way to do this, and I love it. So change counter by 1, and then at the very bottom, change counter by set counter by 1, change counter by 1. We'll go up by, do we want to go up by 1, 1, 3, 3, 5, 5, 7. Seems like we would go up by 2 each time. Okay? Now we need to put counter. We don't want this to change because that's how many sides of the square. Zoop, zoop, zoop. That's always 4. But otherwise, I'll leave that for now. And now here's the problem. I left this as 4 because this always needs to be more than counter. Counter's 1 when we start, but we got to move 2 steps. Once we get here, counter will be 3, right? Because we hit the bottom, we add 2 to counter. Counter is now 3, but we got to go 4 steps. So we couldn't have it here. What we could do, well, we have a few options. Let's look at variables. Math. Notice here in math, here's one thing you could do. I can drag this out. I'm going to get rid of the 1, go to variables, grab counter, and drop it in. So code-wise, what I'm doing here is I'm not making counter a different number. I'm saying take counter and add 1 to it. And so counter will be, this will repeat 1 more time than counter, but the amount counter doesn't change, right? Counter is still equal to 3 maybe, and then it would be 4 times over. But counter, to change counter, we got to use that. Now I'm over on blocks. But this will work. Let's try a different way. Instead of doing it this way, we have this wall path ahead. And so notice, I hit a wall, I stop and I turn. I hit a wall, I stop and I turn. I hit a wall, I stop and I turn. I hit a wall, I stop and I turn. And so now, what if we try to use this instead? Because it will automatically, wall path ahead means I'll keep going until there's no path ahead, which is what we want. That will get me around. And notice now, and you can see me scan the area. So I'll keep going, keep moving forward. Nope, now I get a turn because that was no longer true. There was no path ahead, so I turned. Keep going, no path ahead, I'll turn and run the rest of the code. We did it. Onward.